So now I want to work through a few examples of geometric series, determining whether the series converges or diverges, and if it converges, then we can go ahead and find the sum. So here's your first example, the sum from 0 to infinity of 4 times 5/7 to the n. So first, in determining whether it converges or diverges, you need to identify the common ratio, which is just going to be the base of this exponential expression here. So the common ratio in this case is 5/7. Whenever the common ratio, or I should say the absolute value of the common ratio is less than 1, then the series converges. So, which is true in this case. So this is a convergent series. That means we can find the sum using this formula where I like to express it in words. So first term over 1 minus the common ratio, which is the r. So in this case, first term, we should plug in the starting value for n. So if n equals 0, then first term is 4 times 5/7 to the 0, which non-zero number raised to the 0 power is 1. So this numerator is 4. The denominator is 1 minus the common ratio, which is 5/7. So if we think of this as 7 over 7 here, minus 5 over 7, then this denominator is 2 over 7. And so instead of dividing by that 2/7, we can bring that up and multiply by the reciprocal, 7 over 2. And so we get 28 over 2, so 14. Or we could have just done this. That would have made more sense. But so this infinite sum converges to 14. I think that's our answer. And if you just write sum equals 14, then it is implied that the series converges. If you just would rather write your answer that way. Okay, so as an additional example, let's say you have the sum again from 0 to infinity. So this is going to be example 2, the sum from 0 to infinity of 3 times negative 1.04 raised to the n. So in this case, the common ratio is the base of this exponential expression. So the common ratio now is negative 1.04. So now the absolute value of r would be positive 1.04, which is greater than 1, so this series diverges. And so we won't bother, with the formula, since we know that it doesn't converge to any finite number. So this series diverges because of the value of r there. And I'm going to get rid of this. Sorry guys, I have a small board that I'm working with. Okay, so one more example. This one I have n starting at 1. So the sum from 1 to infinity, this is example number 3. And what I gave you is a little messier. So I gave you 2 raised to the 2n times 3 to the 1 minus n. Just checking with the notes. Okay. So this is a bit of a mess. We would like to see our geometric series in the form some constant times a constant raised to the n. So we need to clean this up. So 2 to the 2n, we can think of that as 2 squared to the n using lots of exponents. And so this is 4 to the n in front here. 3 to the 1 minus n, using another law of exponents, that's equal to 3 to the first over 3 to the n. You guys are probably more used to taking an expression like this and rewriting it this way. So if you see, say, x to the a over x to the b, you're used to writing it as x to the a minus b, so more in this form. We're going the other direction here because we want to separate out our constant raised to the n part of this expression overall. And so this I'll write as 3 over 3 to the n. Okay. So now we've at least got the series written in this form. So that looks a little closer to what we're aiming for here. What you could do now is, I'm going to take this 3, put that in front, and then we have 4 over 3 raised to the n. Right? 4 to the n over 3 to the n. And so now we have a common ratio r equal to 4/3. So again, the absolute value of r is greater than 1, and so this series diverges.